This lesson is about expected values, the variance and the standard deviation of binomial distributions. So I've got a teacher that makes a following offer. So the number of bullseyes, so the number of times you can hit this thing right in the middle, will be the number of days you get off school. Sounds like a pretty sweet deal. You're given two options. You can either go from up close with 10 attempts, but your probability of success is 70%. Or you can take option 2, really far away, but you get 100 attempts. And your probability of success is only 0.07. Okay, so would you rather option 1 or option 2? And give a reason for that. Who knows what your reason is? Write something down. So when you decide between the two, what you should really be thinking is, well, what's my expected value for both scenarios? We've got our formula for expected values, the number of trials times the probability of success. So for both of these options, we'll calculate how many times we expect to hit the bullseye from our number of attempts. So in option 1, I've got 10 trials with a probability of success of 0.7, which means my expected value of NP will be 10 times 0.7, or 7 successes is my expected value. I want you to go ahead and calculate the expected value for option 2. Okay, well done, that was pretty quick. Okay, in both options, our expected value is 7 successes. So apparently it doesn't matter which option we choose. On average, we'll get 7 successes, all good to go. Alright, good lesson. Nah, there's more to that. Is there anything else to consider? Absolutely. We need to consider the spread of the distribution in both cases. Okay, so we need to consider the variance and the standard deviation to see how our results will be distributed, meaning are we always going to get 7, or is there a possibility that in one of these scenarios we might get 0, maybe one of the scenarios we might get, I don't know, 10 days off. Okay, so we need to consider those two. We've got two formulas for variance and standard deviation. So we can calculate variance by multiplying the number of trials, the probability of success and the probability of failure. And for the standard deviation, it's just the square root of the variance, like always. So I'll calculate the variance and standard deviation for both options and then have a look at it. So I'll do it for option 1. So option 1, my variance is NPQ. I know I'm doing 10 trials. 0.7 is my success, so 0.3 must be my failure. I'll get a variance of 2.1. The variance doesn't really mean that much to me. I'd much rather have the standard deviation. Okay, so I get a standard deviation of 1.45 bullseyes. Okay, so again, press pause, you do option 2. Okay, so pretty much where we're at is in these two options, they both have a mean of 7. Option 1 has a standard deviation of 1.45. Option 2 has a standard deviation of 2.55. Okay, so it's really up to you which of these you are happy with, okay, which you think are okay, depending on how much risk you're willing to take. A bigger standard deviation means more variation in the data, so if you want heaps of days off and you're willing to take the risk, you go option 2 because it's got this massive spread, whereas if you're looking for the safe option, you'd probably choose option 1 with a smaller spread. Okay, to demonstrate this idea a little bit better, let's think of recommendations for these two students. So we know that 95% of all outcomes fall within 2 standard deviations of the mean, okay, from normal distributions. So let's calculate for these two options what we expect most of our attempts to land between. So for option 1, my mean plus or minus 2 times my standard deviation would be 7 plus or minus 2 times by 1.45, which means that 95% of scores would approximately be from 4 to 10 when you do the calculations. For option 2, I can do the same thing. Okay, so we can see what our expected range of results is for these two options. Option 1 gives me between 4 and 10 days off for most of the outcomes. Option 2 gives me between 2 and 12. So we can see how the standard deviation is expecting our possible outcomes. So for part A, which option would you recommend to a student who would be happy with 7 days off? I would say option 1. Okay, because there's less risk of getting 2 days off. Okay, less risk of less than 4 days off. Whereas, which option would you recommend to a student who's prepared to take the risk for a longer holiday? Well, if he's or she's prepared to take this risk, they can go with he or she can go with option 2, potentially get up to 12 days off, because they're happy to take the risk that they might end up with just 2 days off. Okay, so option 2, more likelihood of more than 10 days off. Okay, so hopefully that connects some of these ideas of mean and standard deviation with our binomial probabilities, and you can go ahead and have a go at those questions.